Hi, hope you all have had a great weekend. Here's a little polar bear to make what we're doing a little bit more fun. This is section 4.2 continued. We're going to pick up with example 4. We're going to find the upper and lower sums for the region bounded by f of x equals x squared, the x-axis, and the lines x equals 0 and x equals 2. So just to draw a little graph to get ourselves familiar with what's going on in this problem. If you plug 0 in, you get 0. If you plug 1 into x squared, you get 1. And if you plug 2 into x squared, there we go. You get 4. So we have this piece of the parabola. So it's actually this piece of x squared, bounded by the x-axis, and the lines between x equals 0 and x equals 2. So we're just talking about this region right here. And we're going to have to draw a rectangle to figure out if the left end point is going to be an underestimate or an overestimate, and the same thing for the right end point. So the new thing about this problem is they're not telling us how many rectangles to use. So we are going to use n number of rectangles, which means we're going to keep the n throughout the whole problem. So let's just subdivide this up into 4 subintervals. And let's just look at this subinterval right here with this delta x. If we use the left endpoint of this little subinterval, and we hit our curve, and we come over and we make a rectangle, the left endpoint is going to give us an underestimate. And when it does, it's called a lower sum. And instead of using left endpoint, since it's a lower sum, they might use little m sub I for the left endpoint. And if we took every one of these intervals and we used the left endpoint and hit the curve, left endpoint, and this 0 for the left endpoint just makes a straight flat line on the x-axis. So you see that's a lower underestimate. And if we use the right endpoint for this same, well, let's use this interval right here with this delta x. Use the right endpoint and you hit your curve and you come over. That would be making overestimates. These rectangles would be overestimates, which would give us an upper sum. And instead of using right endpoint, they'll use capital M sub I. Now this little m sub I and capital M sub I, they will switch between left and right endpoint based on which endpoint gives you an over or an underestimate. All right, so we need to calculate a few things. Let's do the left endpoint first, which is little m sub I in this case. It's the formula a plus parenthesis I minus 1 times delta x. Let's go ahead and find delta x, which is always found by b minus a over n. We're in the region from 0 to 2, which is this interval. And intervals are always a, b. So it is 2 minus 0 over n, or 2 over n. So delta, I'm going to write it down here. Delta x is 2 over n. So my left endpoint is 0 for a, plus I minus 1 times my 2 over n. This time I'm not going to, yeah, I am. I am going to go ahead and distribute the 2. Okay, so that's my left endpoint. So the lower sum can be found by doing the sum from I equals 1 to n of f of the little m sub I times delta x equals the sum from I equals 1 to n of f of our left endpoint times our delta x. Now, before we go much further, let's go ahead. Well, we can go one step further. F of x is actually x squared. So when we plug this into our function, let's see what we're going to get. So that's equal to the sum from I equals 1 to n of 2i squared minus 2 over n all squared, which means you're going to have to square the numerator and square the denominator times your delta x. So I want to take out as many constants in front of this summation symbol as I can. We're going to bring as many constants in front of the summation symbol as we can. So this 2 over the n, these are constants. This n squared down here is a constant. And every one of these terms here has a GCF of a 4. So we could take, a common factor of 4. So we could take a 4 out. I don't know if you're comfortable with me taking the 4 out of all that. And multiplying it by the 2 out here from our delta x. So I'm going to bring an 8 from the numerator and an n to the third from the denominator. You could go ahead and distribute with the 2 if you wanted to, and then multiply the bottom, and then maybe feel more comfortable factoring the 8 out of the numerator and taking the n squared. Either way. So what I would be left with would be I squared minus 2i plus 1. If I factored out the 8 that way. So I'm going to erase the top so I can keep this all on the same screen. So this 8 over n cubed is in front of the whole summation thing. So I'm going to do a big bracket. And now we're just going to take the sum of each of these parts here. So it's the sum from I equals 1 to n of I squared minus 2 times the sum from I equals 1 to n of I plus the sum from I equals 1 to n of 1. So that is still 8 over n cubed times, well, this is a formula. It is n times n plus 1 times 2n plus 1 all over 6 minus 2 times, this is a formula. N times n plus 1 all over 2 plus, this is a formula. Constant times n. Okay, I'm going to erase some more all the way to the bottom, but if you needed any of that, you could just pause the video or rewind. Okay, let's see. I'm going to choose right here to distribute these. So I'm no longer have this. I've got this n squared plus n that I'm going to FOIL with 2n plus 1. So I'm going to have 8 over n cubed times 2n cubed plus n squared plus 2n squared plus n all over 6. And then I'm going to cancel these two, so I'm going to divide those out, because that's like 2 over 1 times 1 over 2, so they're gone. And then I've got minus n squared plus n plus 1 times n is n. I think I would like to combine these like terms. And I think I'd like to separate all these fractions and put them all over that 6. Still keeping 8 over n cubed separate. So separating these fractions, right here I get 1 into the 3rd over 3. Nah, let's don't do too much simplifying at once. 2n cubed over 6 plus. Let's go ahead and add these together and get 3n squared over 6 plus n over 6. Now here, distribute your negative and bring down your plus n. So I get so torn, like, do I want to reduce all these individual fractions? Do I want to combine like terms? Do I want to get common denominators? Do I want to distribute with 8 over n cubed? So many options. I'm gonna combine some like terms, I think. And 2n cubed over 6, I'm going to call that n cubed over 3. Plus 3n squared over 6, so we'll call that n squared over 2. Plus n over 6 minus n squared, and these cancel. There's no one way that's the best, so just choose a way to simplify and just start with that. Now, I think I might go ahead and make this last n squared a fraction and then get a common denominator with my other n squared term. So multiply them top and bottom by 2 so I can combine those like terms. So we have 8 over n to the 3rd times n to the 3rd over 3. So 1n squared over 2 minus 2n squared over 2 is negative n squared over 2 plus that n over 6. Now I think we'll go ahead and distribute the 8 all the way across and distribute the n to the 3rd all the way across down here. I made that a mess. We're almost done, thank goodness, with the lower sum. So these n to the 3rds cancel and we get 8 thirds. 8 over 2 becomes 4 with an n in the bottom. 8 over 6 becomes 4 thirds with n squared in the bottom. And if you look in the book, my sign is off. Let me see if I can find that. So I'm afraid it's impossible for me to see where I made this sign error. This should be a plus. Because I kept erasing all this stuff to try to keep it on the same screen. But somewhere I made a little sign error and it's not here, the only thing that's still left for me, because that would be a -1. It's somewhere in that problem. You might be able to find it in your work. I made a little sign error, but this is our lower sum. So now we're going to go to the other screen and we're going to use the right endpoints, which are the capital M sub i's, to find the upper sum. The upper sum is the sum from I equals 1 to n of f of capital M sub I times delta x. The right endpoint is a plus I times delta x. So it is 0 plus I times 2 over n, which is 2I over n. So our summation formula becomes the sum from I equals 1 to n of f of 2I over n times our delta x, which is 2 over n. Our f of x was x squared. So when we do f of 2i over n, it becomes 2i over n squared, which is 4i squared over n squared. So we get the sum from I equals 1 to n of 4i squared over n squared times 2 over n. Let's take all the constants that we can out to the front of the summation symbol. So we have a 4 times a 2 on the top for an 8, and we have n cubed on the bottom. Whoa. Of the sum from I equals 1 to n of an I squared. I'm just going to erase right here, I think, if I can try to make that fit. That equals 8 over n cubed times, we have a formula for this. It's n times n plus 1 times 2n plus 1 all over 6. Let's see, this time I think I'm going to reduce this n with this n to the third and make that n squared. I'm going to reduce 6 to 3 and 8 to 4. So that's 4 over n squared times, and let's go ahead and FOIL these. All over 3. Now we'll distribute all the way across. And this one's almost done. So now this is equal to, let's go ahead and combine these like terms, and then let's do I love math and simplify everybody out. So we get 8n squared over 3n squared, plus when we combine 4n and 8n, we get 12n over 3n squared, plus 4 over 3n squared. The n squareds cancel and we get 8 thirds. 12 over 3 is 4 with the n in the bottom. And this would stay the same. And my sign is wrong again. This sign is wrong again. It's supposed to be a negative. I don't know where my mistake was. I'll try to rewatch the video and see if I can find it. But that's our upper sum and that's our lower sum. The last thing I want to talk to you about is actually, I think that is good for today. That is good for today. Let me let you try one, doing an upper and a lower sum with an n. Let's go ahead and try. Please try for me on page 264. Let's try number 47, I guess. And let's just do the upper sum. All right, I'll see you all Wednesday.